Welcome to part 3 in this video series where we are looking at the creation of an Excel sheet that you can use to collect and manage training load, primarily for team sport athletes, but you could apply it in different scenarios if you wanted to. What we've looked at so far is the basic data collection process and how you can do a little bit of simple reporting with a pivot table. What I want to go through today is a little bit more of the nuts and bolts and the calculations around how you might add information to your existing training load data set to allow you to do things a little bit more simply and easily. In particular, talking about rolling loads, so whether you're collecting 3, 5, 7, 28-day rolling training loads, you're looking at things like acute and chronic load, and potentially also the application of monotony and strain too. So let's go to our database sheet, and we've got a very simple data set. It's quite a big data set. It goes down quite a few rows. I'll just double click on the bottom of the selected cell. You can see I've put in quite a lot of rows of data here, so that will allow us to really get in and amongst some of the calculations further down the track. And as you can see here, and as you might have heard me talk about in other videos, the key to doing good analysis with your data is to have plenty of descriptive fields. So at the moment we've got 3 descriptors and 3 data fields. So the 3 descriptors are date, athlete and training type, and then we've got our data to the right of that, which is just duration, RPE and load. I want to add 2 more descriptive fields here. The first one is a time related field, which is going to be week. And I think training weeks are pretty useful in this process because a very sort of common way of analyzing the data at the moment is to look at things like acute and chronic load. So comparing recent training load to the last 28 days or even further back if you wanted to, and a week field helps that a lot. Now you could do something very simple here, and that could be simply to create a list of weeks, week 1, week 2, week 3, and just manually select it from a drop down box when you are entering the data in. That is just fine, but what's even better is being able to use a lookup formula to do it for you, so that as soon as you enter a new date, the week automatically populates. So we've looked at this in other videos, but let's quickly go through it again now. All of my files have a control panel sheet where we can store things such as lists of player names, dates, and other things that might become a part of a drop-down list, for example. One of my 3 tables here is called a date table, and I simply have written down week 1 to 20, and next to it I've just put the Monday of each week. And so if I wanted to simply put in the first day of week 1, the 4th of the 1st 2016 is what I have chosen, and then every week after that is just plus 7 days. So it's quite easy to create this table. But now that we've got this table, we can refer to it in our data set. Just before we go and do that, I just want to go into the context menu. We can see the name of this table is called TBL dates. Back to our database sheet, and now I'm just going to start typing a lookup formula. Index. What am I trying to look up? Well, I want to look up, for a start, the table called TBL dates. What I'm looking to return is the week. And how am I going to identify the correct week to pull in? I'm going to use the match function for that. I'm going to match whatever date is entered in column A by looking in the date table, this time in the day field. And rather than an exact match, which is what I would do if I was looking up an athlete name where there's only one correct answer, in this case there's 7 days that might be a part of this week, so I need to do type 1, which is a less than match. When my formula tip disappears, I know I'm finished, so an extra bracket, and then that formula tip disappears and I can hit enter. One of the beauties of Excel tables is that all 1200 plus rows are going to populate automatically. And it's now saying week 1, and if we go down far enough it switches over to week 2, so that's working just fine. We could have just selected from a drop down box, but this is even better. Now the second thing that I want to insert here is position. I think in some sports such as field hockey and football, there may not be enough differences between positions on the field in terms of how much they cover and the type of training they do day to day to warrant this position breakdown. But certainly in the case of rugby, which is what this example is looking at, there's some quite big differences in body type and training activities, so a position breakdown can be very helpful. Because I've inserted a column in between two existing ones, it's copied across the data validation settings from the athlete column, which is column C. I don't really want that, so I've got my cursor in D5 at the moment. If I hold down Control Shift and then the down arrow, it selects all the way to the bottom, and I can change this to any value. Now I can type anything I like in here and it's not going to give me an error message. So I did this just a second ago with an approximate match, but this time I'm going to do it with an exact match. So index, we've got a table called team list. Now I couldn't remember what I called that, but because I used that TBL prefix, all these names present themselves, and if I label them with a very sort of simple descriptive name, it's pretty easy for me to see that team list is the table that I want. I usually call it something like player details table or player reference, but in this case I called it team list, and I know that this is the one I want. Hit the square bracket, and on a PC, really easy to find which field I'm looking for. So I'm going to return their position by looking up with the match function, player name, in the team list table, in the names column, and this time it's an exact match. Keep hitting the brackets until formula tip disappears, and if I hit enter it copies down. Going to undo that and also do a VLOOKUP just so that you get a feel for both ways. VLOOKUP's a little bit easier to get, so let's try that as well. I want to look up the athlete name in a table called team list, returning whatever's in column 2 of the table, and an exact match. So that formula is shorter and easier to understand, producing that same answer, returning the position for each athlete. And so now when you put new data in, as soon as you put the date in, week auto populates. As soon as you put the athlete in, position auto populates. Alright, so that's the easy bit of the lesson. The next thing we need to start to do is to build out some of the analysis data that we've got to work with. And so we've got load now, but wouldn't it be great if we could do a little bit more than just look at load? First place to start is to put just a rolling load. I find this particularly useful, and there's lots of different ways you can look at it. 3-day load, 5-day load, 7-day load. There's lots of ways that you might be able to make sense of your data rather than just looking at day by day. Rolling load is something that I find especially useful, so let's talk about how you might calculate that. So if we have our data defined well, we have an athlete name, we have a date, and even a week as well, we can start to use those to give us these rolling calculations. We want to do a multi-criteria sum. SUMIFS does that for us. First thing to enter is sum range. Once again, I've forgotten what I called this table, but by typing TBL, it brings up a list of all my tables. And I can see that it's TBL data, and I know that's correct because When I tab it across, it selects the whole table. What are we wanting to include in our analysis? Load. I've got a bunch of hidden columns here, which is what some of those extra fields were, in case you were wondering. So I want to give the sum of load. This column is now highlighted in a blue box, so things are moving along nicely. Now we have to put our criteria in. The way you should order these criteria is the criteria that's going to filter things the most, you want to do first. That'll make the formula calculate faster. I'm going to choose to do the athlete name first. So we need to put in the table and then the field name. So that is athlete. And our specific criteria is the athlete name from this row. What's our next criteria? It's date. And how do we want this calculated? We want today and the previous 2 days. First criteria is that it must be less than or equal to today's date. And because I am using a operator, which is the less than or equal to, I put that in quotes and then I have to join it together to the date field. It's a little bit tricky, but once we get this formula working, we can copy it and use it for the other 3 columns with only a very small edit required. So that's the first bit that we need to put in. It needs to be less than or equal to today's date. We can save time by copying that and pasting it, because that's our third criteria. Instead of being less than or equal to, we want it to be greater than today's date minus 3. Close bracket, we can see the formula tip disappear, and I hit enter and it'll copy all the way down. Why don't I filter just by Andy Jones, and we can just have a look and see if that's working correctly. We've got 3 days here in a row, 4, 5, 6. It's not until the 3rd day that this formula will be calculating correctly, because there's then 3 days worth of data. So we've got 320 plus 880 plus 585, and we can roughly guess that that 1785 is correct now. When we go to the next one, which is the 7th of the 1st, we can see the 320 drops off and the 735 comes in. So again, that looks correct. I think we've got that formula right. We can go back, select all our data, and then finish off these other 2 columns. So copying and pasting. I like to do that inside the formula bar because it removes any risk that we might get some automatic changes happen without us knowing. Instead of having minus 3, I want to have minus 7. Everything else can stay the same. Hit enter and go into 28 and change 28. Now we're not going to see much value in this rolling 28-day load just yet. We kind of have to get a month's worth of data before that actually becomes useful. So these first sort of 28 days for each athlete are going to be an incremental increase in that rolling load until it then stabilizes at that 28-day mark. I have a colleague that works with a team sport here in New Zealand, and he uses a 10-day training block, and so for him the acute load of 7 days actually might not be that relevant. For him it's 10 days, and so he can simply change the formula to 10 there rather than 7, and that's something that you need to work on as well. Figure out how to best do the analysis in your specific environment. The next bit to look at is the calculation of chronic load. Before I do that, I just want to reduce the size of some of these columns here on the left so we can see everything we're looking at. I've put little comments in here, and what it's saying is that week 0 is the current week, the sum of load over the last 7 days. That is exactly the same as the rolling 7-day load, so I can copy that and paste it in here. Once again, these first few rows aren't giving us accurate data because there's nothing in the previous 6 days, but as we get a week in, this number becomes a little bit more relevant. And so that's this week. What about last week? I've called that week minus 1. And so that is the sum 7 days ago to 14 days ago. Why don't I copy this? Paste it in. Let's think about what this formula needs to look like. It needs to be less than or equal to date minus 7 and greater than date minus 14. Zeros for now, but as we scroll down, we'll see these numbers start to appear once we get to the right number of data rows. Let's keep this rolling. This one's minus 14 and 21. This one is minus 21 and 28. And this one is minus 28 and 35. And so just take a moment there to look at how I've labeled this, because it's something that you need to define yourself. How are you wanting to compare current to chronic training load? I like comparing the current week, I call that week 0, to the 4 previous weeks. Other people like to look at this week plus the previous 3 weeks as being their chronic load period. Whereas I prefer this week to be treated separately from the previous 4. So I've got 5 different week calculations here. Week 0, week minus 1, week minus 2, week minus 3, and week minus 4. When I have these 5 columns laid out, it makes it very easy to change my definition as I see fit. And so if I'm trying to get the average weekly load for the 4 weeks prior to this week, then because I've got these helper columns, I can do that really easily. Simply by doing the average of these 4 cells. Because they're all 0, it's going to be very unspectacular in these top few rows, but I'll drag the sheet down and we'll start to see it appear and be somewhat stable and relevant as we get deep into the data set. So now that I've got that column Q, which is the average weekly load for the previous 4 weeks, I can compare that to the training load for the current week. Let's do that. What is the acute load? I've defined that as week 0, current week. What is my chronic load? I've defined that as the previous 4 weeks. And I can't quite click in that cell here because my formula is overlapping, so I'm going to click below and then use my arrow key to go up. Something's not right here because I can't divide by 0. But let's drag down and we can see it kicks in just fine after that. Those div 0 errors are very ugly though, so I want to avoid them from annoying me by putting if error in front. What it really does there is blank out everything that's got an error, but after that it looks pretty good. If I just pause here for a second, what we can see is that for each person every day we've got an acute to chronic load percentage. Now the problem that I've found with doing it this way is that you get a lot of swing in these percentages because you're doing it every day. All it takes is one big training session to throw out quite a large change in acute or chronic load. It may be better to do it in a weekly summary table rather than a daily row by row analysis. I'll show you that in a second. The other thing that I wanted to do was something that I actually find very useful, and that is what change have we had since last week. And that's a pretty easy calculation. I'm going to put if error straight away in there. But what am I really trying to say? What is this week's load as compared to last week's load? That's it really. What sort of change have we had this recent 7 days to the previous 7 days. Again, nothing in these first few rows because there's no history, but drag this down and we start to get some numbers. Alright, so we've calculated that acute to chronic load percentage every day for every athlete. And as mentioned, that can give you quite a lot of swing and fluctuation in those values. Let's have a look at how you might do it if you were doing it with a weekly summary table. I've got a drop down box at the top here that allows me to pick team or any individual athlete. Let's look at the number of sessions. We want to do a multi-criteria count. What's my criteria range? TBL data, athlete equals team, TBL data. This is where the week column of data becomes very useful. So it's telling us we've got 7 sessions in week 1. Let's copy this down and have a look. So we've got 5, 6, 7, things like that, all the way down to week 10. When you have a relatively low number of training sessions like this, that's when you see quite large fluctuations in that acute to chronic load calculation. One training session can cause a 15 to 20% increase in training load for that week. And so I think that acute and chronic training load works really well for professional team sports where they have a pretty consistent week-to-week schedule, a relatively standard number of field trainings and a relatively standard number of off-field trainings in a given week, and so you get much smaller changes from one week to the next. But when it's low numbers like 5 or 6 per week, sometimes you do get a little bit more swing than you might otherwise get. So we've got that countifs there now. Let's have a look at total duration. So we're summing duration using a double criteria. First we've got athlete, and next we've got week. Can't see it again, but I can use my arrow key to get there. I've just taken some liberty there and gone away and done the average RPE and the total load. The one difference that you might look at if you are climbing into this formula is I put a little switch in place that says only do the calculation if there were some training sessions. So don't do it down the bottom here. When it gets to week 11, there's no training sessions, so don't do the calculation. So what I've said is that if C6 is greater than 0, then do it, otherwise leave it blank. This is just a regular grid of data. I haven't converted this to an Excel table. And one of the things that I can now do is use different formula in each row. And so for our 4-week load, there's not a lot I can do here because there's nothing prior to week 1. So really the best I can do is just directly reference that. And the next row after that, I can do this. The next row, I can do that. Now it's starting to get useful. I've got 4 weeks worth of data now, and so that 4-week chronic load has got a little bit more accuracy. You'll remember that in the previous sheet I did this week as the acute and the chronic the previous 4 weeks. So again, it's about being clear. Do you include the current week or not in your own chronic load calculation? If I'm being consistent with the method I chose previously, then this chronic load will be calculated by looking at this set of numbers, like so. So week 5's chronic load is the average weekly load of weeks 1 to 4. Now I can just copy this down and these formula will stay relative, as you can see here. This is a piece of cake now. What is my acute load? What is my chronic load? You can see we've got an error, so what should we do? We could either put a switch in, like this, I did this one a second ago. If C6 is greater than 0, then do the calculation, otherwise don't. That would work. And so would if error. If error for a formula like this doesn't really have any cost to it, but if you do if error in front of thousands of formula, in particular if those formula are complicated, like a big average ifs calculation, then it can suck the resources out of your computer. So Excel will need to do the whole calculation to figure out if there's an error or not, and then it just chooses not to display it. Whereas here, it doesn't even bother. If there's no training sessions, it doesn't even do the calculation, so that can save the processor quite a lot of effort. Let's look at our weekly load change. Now I can do this in a couple of ways. I could get a number such as 10% or 15% by doing the calculation one way, or I could get it as a simple ratio of this week to last week. So let's try it the easiest way as far as formulas are concerned. It's really just this week divided by the previous week. And so we get 62% here, and if I copy that down, wouldn't you know it, we get some errors again because you can't divide by 0. This time, why don't I just do if error? That way you can see that there is multiple ways to prevent and control how your errors come out. Alright, so we have now some quite useful info based upon a weekly summary grid rather than doing it row by row in the other table. We are back in the big database now, and I want to go through both here and on the weekly summary table the creation of monotony and strain. I don't have a lot of time for monotony and strain in team sports. Personally, I wouldn't use it, but I know it's an interesting area that certainly has some merit. I just haven't found it to be as useful as things like acute and chronic load. But let's check it out anyway. What have we got here? We've got the desire to have what is the standard deviation of training load for the previous 7 days. That's the first step, and easily the most complex formula of everything in terms of calculating monotony and strain. So let's try this out. Unfortunately, we've got AVERAGEIFS, SUMIFS, COUNTIFS, and in Excel 2016 we've even got MAXIFS, but we haven't yet got standard deviation ifs, and so we have to do something a little bit harder to get this to calculate. I'm going to type standard deviation. Now there's a whole bunch of standard deviation options now. You can see that there's a little yellow triangle around these two, and that's because they are legacy solutions. If I click on one, you can see it's even trying to convince us not to do it. So let's choose this one, standard deviation S. It wouldn't matter if you did the regular standard deviation here. Once we're inside this, we have to tell Excel how we want the standard deviation to calculate. I need to do an if function. I need to say that for a start, it has to be the athlete that I want. If the athlete equals this athlete. And I've got a second criteria as well, which I have to put inside another if. If TBL data date is less than or equal to the current date. And I've got another criteria which I have to put inside another if. It also has to be greater than date minus 7. And if it is, the field that I want the standard deviation done on is load. Crikey, that's a pretty tough formula and I can certainly forgive you for getting that wrong. I don't need to put false in here. I could put a comma and then a double blank quote, but I'm just going to close it. Not once, not twice, but 3 times. And what that's going to give us if I select all of this and hit F9 is an almighty string of data which is mostly false, but if you've got good eyes you'll be able to see that there's one that says 320. That's the only record that meets our criteria. I'm going to Control Z that, reduce down my formula bar again. Close bracket on the standard deviation. Critical bit, we've done this a few times before. This is an array, so I need to do Control Shift Enter. We've got some error values in there. The reason there's an error is because you can't do a standard deviation when there's only one value that meets your criteria. As soon as we get to the second data set, it works okay. Why don't I pick one of these, go back in, select the inner workings of the formula and hit F9. What we'll now see is that there's a few more numbers that meet our criteria. So we've got a 160 in there and a 180 and so on. So it's starting to work for us. But the critical bit, each time you enter it, Control Shift Enter. So we've now got that 7-day standard deviation. And with that, everything else is a little bit easier to figure out. We have to figure out our 7-day average load as well. We can do that with an AVERAGEIFS, and we've done that before, so hopefully you've got enough confidence to be able to understand that. We want to average the training load for this athlete in the previous 7 days. Copy that down, and we can fill in just a basic count function and our monotony and strain values just using the standard formula. When I said that there's quite big fluctuations in training load early in the data collection cycle, it's even further exacerbated when you look at monotony and strain. You can see how much a small little change does to the strain values. That's what I don't like about it. You get very significant differences between athletes caused by very small differences in their RPEs. So at a day-to-day level, I don't think monotony and strain's useful, but at a weekly summary level, it's not too bad. Alright, so I have repeated that process just to save time in this weekly summary table. The formulas are exactly the same, but it's a bit easier over here because I've leveraged off that week label. Still have to do Control Shift Enter, so don't forget that for standard deviation. I'm sure Excel will figure that out soon enough. There'll be a standard deviation if, but there isn't at the moment. Then we've got average load, and then those basic calculations of monotony and strain. And so this weekly summary table is actually quite helpful now. We can do things such as create some really simple charts that allow us to look at just the flow over time of all of these different variables. Why don't I take some liberties and do that quickly? And so there we are. I've put load and duration on one chart. I've got acute to chronic load ratio there. There's certainly nothing to cry about. No values getting up above sort of 140, 150%. There's a couple that are a bit low, like this one here, 76%, but still within the ballpark of what we would consider acceptable. So this weekly summary is quite cool, and you can just choose an individual athlete if you want to, and everything will update. And yeah, that's a nice way to be able to quickly see whether or not there's any big spikes in either load, duration, monotony, strain, whatever it is you find the most useful. And so if we're back in our database, I'll expand these out again so we can see them in their full glory. We've got these real keys to the success of the spreadsheet working is at these descriptor fields. We've got a week now, a position and a training type, so we can look at some interesting breakdowns. And as we go across, Your definitions are required for how you're going to do acute and chronic load. I've got 5 different weeks being calculated here, week 0, 1, 2, 3 and 4, and that allows you to choose how you want to calculate acute chronic load and this other stuff here, the monotony and strain. We've spent 3 videos looking at the creation of spreadsheets that'll do the data collection, and the most recent one, part 3, looked at ways that you can add layers of complexity to your calculations. You can do rolling load, acute load, chronic load, monotony and strain, and things like that. All of that stuff's fine and well, but unless you can apply the data, then it's relatively worthless. The question is, what are you going to do about it? How are you now going to plan with this additional data and knowledge? I've just come out of an Olympic cycle. The Rio Olympics just finished, and that's a really good example of being able to practice your preparation. So in the lead up to a major event, you might have a 12-week lead-in, and you can practice that several times over a 4-year cycle and learn from it. Figure out how one player might feel and perform better under a particular loading structure as compared to a different one. Just like with wellness, generic applications of training load aren't that effective. It's about individual strategies, figuring out, does this athlete need to be trained more or less to get them into the right state they need? Let's go to a sheet that I've put in here called Planner. I want to talk you through this process. We've got 10 weeks of data in the load database sheet, and we are trying to prepare for week 11. And so for this individual athlete, I can put in my plan for the week in advance. I've done that here, and I've got 5 days of training, a day off, and then a match at the end of the week. On the basis of these things, we've got some hypothetical RPEs, durations, and training loads being calculated. All of that's being summed together, and it is adding a new row of data to our data table, and it's allowing these graphs to be drawn. So the blue line is the current week. You can see that if I change Friday's training session, which is currently 45 minutes, why don't I change it to 150, and you'll see those charts change. So the grey bars are historical data from the database. The blue bar is the week that we're currently planning. And so what are we getting from this view? We've got the ability now to plan the week out. We know what we're trying to achieve, and we can check to make sure that it's not violating any of the principles that we're trying to apply. Is the acute to chronic load ratio too high? Is there a too big a difference between last week's load and this week's load? Things like that might help us decide that we need to make a change. And so let's look at the first chart. We've got training load. The planned week is blue. The previous 6 weeks are shown in grey bars there. So we can see that the profile is relatively steady. We've got the acute to chronic load ratio in the dashed thick black line, and above and below that is a thinner dashed line, which has got a little bit of a tolerance there. It's almost like an error bar. It's saying that minus 50% and plus 50% is our upper and lower limit of tolerance to this training load. This blue bar here has got a complex label on it. It's got 3 points in the label. What is the load? 3,780. What is the ratio? 125%. So that's the acute to chronic load ratio. And what is the comparison to last week? 117%. So that means that there's a bit of an increase since last week, but the ratio is still within our acceptable means. Across on the right, we've got the percent change load shown in a different chart, that there's a 17% increase, and underneath that acute to chronic load ratio just in its own chart to make it very, very clear. Let's go up the top here and think about it. Compared to previous phases, is this training plan and loading system okay? Well, how do we know? Well, we could create a little grid, and I've done that here. I've called it the load reference table, and I haven't filled it up with lots of information, but what I've got in here is that we did a similar preparation in the lead up to the World Cup in 2015. We had 6 weeks of training before the major event, and this was the load that we applied. I've got a second team reference point that says we did a really heavy block of training, and this is what the 6-week load was there. And for this individual, this is what they had in the 2015 build up to the World Cup. I could change this to anything really. It was just really to illustrate that if you learn from one phase, you might find that a given athlete was not getting injured, they were reporting really positively in their wellness scores, they were attending sessions regularly, they weren't missing anything through to illness or injury, and they performed really, really well in the major event. And so you might have that as a reference point forevermore to say, remember last year, this is the training load we did, and this is how you performed. Sometimes that can give athletes a high level of confidence. And so if we go to the planning sheet, I've got previous examples in these purple squares on the chart. It's not always easy to add more and more data to a chart without it looking ugly. So I've just put these purple squares in there to not be too conspicuous. At the moment, we've got Gary Parks. We're referencing this athlete against their own data points. How about if I reference them against the team or against a different phase? And if we know how this athlete performed during the cycle, we can say that this is a good model to follow or it's not. So we've got that previous reference. What about another player? If we don't have a strong history of information on this athlete, we might compare them to a similar player, similar fitness, similar physique, for example, and say, well, it worked for Joe Jones, why wouldn't it work for Gary? You can look at their trend and wellness scores. Are they trending upwards or downwards with their sleep, their fatigue, their soreness? How about their performance scores? You may collect information in matches or even at training sessions that allows you to say, well, he's actually training really well at the moment. Even though his load scores are going up, things are going exceptionally well. If you're deciding about the removal of training load from a program, such as in this case here, you might look at his requirements or training needs. If he's really, really bulletproof, his fitness is high and his strength is one of his real assets, then you might be able to be confident that we can actually do without this extra strength and power training session, because he doesn't need to work on that. He's got that in spades, and therefore this makes perfect sense to cut that one out. But if he's carrying a bit of extra weight and his aerobic fitness is down, then it's not always ideal to be removing that aerobic stimulus, because that might be the thing that's protecting him from injury. So training needs is really important way to determine whether or not sessions should be cut out. And also, and critically, you can look at, are they on the physio table or not? If they're not, you could argue that they're tolerating training load just fine, even if their acute to chronic loads are relatively high. And so you go down and you check things out and you figure out that actually we still need to cut a little bit more load out. And so what can you do? You might make this training session 90 minutes. Or even more so, you might decide that we need to make this a much more technical session rather than a physical session. Take the RPE down, change the content of the session a little bit, and therefore have quite a significant impact on overall training load. So these are the decisions that you need to start thinking through when you're looking at making modifications to your training to try and fit within a preconceived idea of how much training load you want and whether or not a given week's plan is going to be effective or not. And so you go through that process for the entire team, or for individuals, which is even better, but you probably start at the team approach. And the way I put this together really was just with the help of a workings table. So I put that on the control panel sheet. So every session has a title, a duration, an RPE, and a load. And so on the control panel sheet I've got all of that stuff combined into one grid. And these are just direct references to the other sheet. Having that direct reference allowed me to shake it all down into one grid. This is the entire training for the week. And even more so, what I've got here is a little bit of a helper table that's saying, on the basis of my plan, this is how much training load is being incurred in each part of the week. And this might give you insight into the sessions that could be modified the most readily. So if you've got a long and hard training session, it's obvious that making a small change to that is going to have a great decrease or increase in RPE duration. And so then back on my planner sheet, this little grid down the bottom is just sucking out things such as duration, loads, and plotting them on these charts here. So for me it's a matter of saying, well, actually, why don't I include in this file their wellness data? I didn't want to complicate this sheet by putting it in. I wanted it to just be about training load, but let's pretend that we have inside our load database, we have a column that has overall wellness score. What if we also had a column that said some kind of performance metric? This could be based upon training session, matches, or a combination thereof. So suddenly we've got the ability to overlay information on this primary chart here that says training load's going well. In previous years or phases they have coped with this amount of training load just fine. When they did this amount of training load they performed well and didn't have a lot of injuries or muscle soreness and fatigue. And so therefore I can be confident that 3,400 training load points is going to be okay for this athlete next week. And you can move on to the next player in the team and make some more decisions. And so I haven't gone into some of the details of how I constructed that lookup table, but if you want this file, feel free to email me and I'll send it through, and you'll be able to see that none of those calculations are particularly complicated. It's really just an extension of the work that we've done in the previous videos. There's just one more thing I want to do before I wrap this video up. I realize it's quite long already, but that is to create an individual report. I did some of this work in videos A and B of this series, but they used pivot charts, and I appreciate that there are a lot of Mac users out there that can't use pivot charts. So I'm just going to go through the process of creating an individual report using pivot tables but not pivot charts. So let's just check out our blank athlete longitudinal report sheet. We've got nothing on there now. We can go to the database sheet and start building. Now you'll notice that I have added and shaded with a black heading just to make them stand out some wellness numbers. I talked about that a few minutes ago and said how nice it would be if we could include some of that in our load decision making. And the other thing that I have added in here is 3 GPS metrics: distance, high intensity running, and very high intensity running. And the final one, just a match impact score that's mostly blank, but on match days there is now a value for their contribution to the match as based on some performance analysis metrics. So as long as I'm inside the table, we can start off with our first pivot table. We want to put it on an existing worksheet and leaving a few blanks at the top underneath the heading there. I'm going to click an A10 and then OK. And so building a pivot table is something you should practice if you're not already good at it. You can do some pretty quick and fast analysis this way. So the date field I'm going to pull down, and you'll notice that months already got grouped in there. That's something that Excel 2016 now does, automatic grouping by date. I actually want to get rid of that month and instead pull week down. So I could have week above or below date, but if I have it below, it doesn't really look very good on the chart. So week first and date second. I'm going to put athlete in the filters, but I'm going to use a slicer to do that, so I'm not going to drag that down into the filter part of the grid. I'm going to move on to our values and just picking a few, such as wellness score, duration, RPE load. Let's do very high intensity running and match impact score. And so I've got 6 variables in my pivot table now. I'm going to close this down to get it out the way and start working on the tidying up of this pivot table. Starting with the first, I want average wellness, and I want the number format just to 1 decimal place. We've got a couple of errors showing there that suggests that there is no data on that day, and because we've got average as our formula of choice, it's going to come up with an error if there's a blank. So we can solve that in pivot table options. There's a box that says for error values, what do you want to do? Just tick that box and leave the second part blank. It just makes those errors go away. Just going to replace that heading, and that's a little bit tidier. Under summer duration, that looks okay. Previously I went into just this right click menu here, but this time I want to go into value field settings because I can do both things here. I want sum, I want a number format with no decimal places, and I just want it to be called duration. Doing it in one place has got its merits, so pick and find your method. I'm going to keep AV in front of the RPE just so we've got that clarity. And so there we are, we've got this sorted out now. I've tidied up all of those fields. It doesn't look that great right now because it goes off the bottom of the screen, and I think that right clicking and choosing collapse entire field is a better option. Now there's one thing that I've always found very annoying, and that is that 10 comes after 1. But there's something that is pretty cool actually. If I select on that 10, I can drag it down and manually place it at the bottom, and from that point on Excel will just continue with that layout for me. So pretty happy about that. I can now have them in the correct order, and because each week has a plus sign next to it, I could expand it out and have a look if I wanted to get into the detail. I talked about having a slicer for athlete name, so let's put that in. Slicers now work in Mac Excel 2016, so you should be taking advantage of them if you are a Mac user. I'm going to pop that just above the table. And increase the columns out by enough so that we can get all of our athletes in. I might have to insert just another couple of rows here. Just to make it look a little bit better. There's a style menu. I prefer the darker style. That way we can have much greater clarity about what we're looking at. So whether you're looking at the team or an individual, it's all the same here. Might also choose a style for this pivot table. A medium style I think is a good option. Where it's grey until you expand things out and you can see the detail in white. I've never been a fan of grand total, so they're gone. If I copy this whole pivot table and paste it next door, it's now going to borrow from the same cache of data, so it's going to be a little bit leaner in terms of the size of our workbook. It's not going to take as long to calculate or be as large. So I like that, and it also means that the same slicer will be interacting with the second pivot table. If I click inside, bring back up the field list, this time what I want to try and do is take the week out. And at the moment it doesn't look great, but bear with me. From inside the pivot table, insert another slicer for week. Because this is a new slicer, it's not going to by default interact with our first pivot table. But what it is going to do is allow me to look at a bit more granularity without having to expand out the pivot table on the left here. So I can just choose week 1 or week 1 and 2 and see a little bit more detail here. I could go and put a particular style in of my choice. Doesn't really matter too much. But therefore we've now got slicer on the left interacting with both pivot tables, but only the slicer on the right interacting with the right hand pivot table. If we wanted to, we can do a little bit of fancy work to recreate pivot charts. So let's have a little go at that. First thing that we need to do to help us with that is do a counter. Let's use the match function to figure this one out. Inside a pivot table, dates are actually stored as text, which is unusual. It's not what happens in a normal situation. So I'm going to look for something that is ZZZZZ. And just in case I've got 100 items selected, I'm going to go down 100 rows. And when I close that off, it's going to tell us that there are 5 items in there. If I check a couple more weeks, it expands out to 16, so we can see that number is increasing. And that count is useful for us because it allows us to create a dynamic range or two. We can do that in the name manager. And let's just do 3, dates, wellness, and load. If I click on the first one, dates, and choose define name, the good thing about that is it populates for me in terms of the name box. Where's our range going to start? It's always going to start in this cell. And where's it going to end up? It depends on our counter, but the index function allows me to say that somewhere in this range it's going to end based upon our counter. If I copy that, makes for an easy process for the second 2 that we're going to do. Let's have a look and see what it's done. Here it is, dine dates, and it's got just the cells that we want. So it's worked great. Let's define another one. All we've got to do is move it across to the correct column. Wellness is in L. Click OK, and finally load. Loads in O. And we're good to go now. Now what I can do is set up a dummy set of data and then replace it with our dynamic ranges, or I can just go from scratch. Let's see how we do that. Insert. Let's choose a line chart. And if we right click in it, we can choose select data. If I backspace away those cell references, I can simply type in the name that we created. Dynamic dates. And our range can also be pretty simple. Just manually typed in DYN well. And what we've got here is the first of just a couple of simple charts. We'll tidy that up in a second, but first let's create the second one. I right click on it. The only thing I need to do is change the name of the series and very quickly just change the range that it's pointing against. Probably makes sense as a line, but I'm going to convert it to a column anyway. Tidy things up just a little bit. Take away a bit of clutter. And so what we can see now is that we've got the ability just to change these charts using the slices. But importantly, these are not pivot charts, and so therefore you're not getting that compatibility problem on the Mac. So I'm going to stop there and leave you to do your own reporting. If you want a copy of this file, feel free to email me or go to this website to download